Hi guys, welcome back to this concept-based YouTube channel. Today we'll discuss class 9 maths problem, exercise 2.4, chapter number 2. As we can see the question, we have to find the values of k if x minus 1 is a factor of px in each of the following polynomial. Now, first of all, we are given with the first problem in Roman number 1 as p of x is equal to x squared plus x plus k. Now let us start from here. First of all, let us write solution, and same as the question it is written, you have to write it down, equal to x squared plus x plus k. Now what is the question? What is this? Here the question has given us x minus 1 is a factor of px. We have to write the one in order to find the values of k. Here it will be x minus 1 is a factor of px. Let us write therefore, if x minus 1 is a factor of px, then px must be equal to 0. And here let us write that is, first of all let us find the values of this one. Let us put this one, x minus 1 equal to 0. And after that, if you move this minus 1 on the other side, then you will get 1. Now what is the values of x that we have in hand? It is 1. Instead of this, we have to write it 1. Now let us check this one, p of x is equal to x squared plus x plus k. Instead of this, we have to put the values of x in each of this. It will be 1 square plus 1 plus k equal to 0. And 1 square plus 1, it will give you 2. 2 plus k equal to 0. Now if you move this plus 2 on the other side, then it will become minus 2. So what is the values of k that we have? It is k is equal to minus 2, right? Then let us move to this Roman number 2. We are given with p of x is equal to 2x squared plus kx plus root 2. Now what is the question has given us? The question has given us x minus 1 is a factor of px. Let us write that one. If it is a factor of px, then px must be equal to 0. Let us find the values of x from here. That is x minus 1. Let us make it equal to 0. And after that, if you move this minus 1 on the other side, then it will become plus 1. Now the values of x that we have in hand is 1. Instead of px, let us put 1 equal to 0. What is the values of px that we have? It is 2x squared plus kx plus root 2. Now let us put the values of x equal to 1 in each of this. 2 times it will be 1 square plus k times 1 plus root 2 equal to 0. Now 2 into 1 square will give you 2, and k times 1 will give you k plus root 2 equal to 0. And if you move this 2 and root 2 on the other side, then it will become minus 2 minus root 2. And how can you write this one? You can take minus as common. Let us take minus common. Minus into plus is minus. It will be 2 here. Minus into plus is minus. So this is the values of k that we got from Roman number 2. Is it clear to all of you? Alright, then let us move to this Roman number 3. Here we are given with p of x is equal to kx squared minus root 2x plus 1. Same as the problem that we did just before we solved this. Even here the process will be same. X minus 1 is a factor of px. Let us write that one. And after this, if x minus 1 is a factor of px, then px must be equal to 0. And here let us find the values of x. Let us equate x minus 1 with 0. And if you move this minus 1 on the other side, then it will become plus 1. Now let us use this condition, p of x is equal to 0. Instead of x, what do we have? It is 1. Now let us use the values of x. It is p of 1 equal to 0. What is the values of p of x? It is kx square minus root 2x plus 1. Here let us use theta 1 instead of x. Let us put the values of x that we got just now. It is 1. Root 2 times 1 plus 1 equal to 0. K times 1 square will give you k, minus root 2 times 1 will give you root 2 plus 1. Now if you move this 1 on the other side, then it will become root 2 minus, this root 2 will become plus, and this plus 1 will become minus. So this is the required value of k that we found it from Roman number 3. Clear? Now let us move to this Roman number 4. We are given with p of x is equal to kx square minus 3x plus k. So what is the question? In the question, we can see that x minus 1 is a factor of px. If x minus 1 is a factor of px, then p of x must be equal to 0. And let us find the values of x by equating x minus 1 with 0. And if you move this minus 1 on the other side, then it will become plus 1. Let us write now. Instead of p of x, we'll write p of 1 equal to 0. What is the values of p of x? It is kx square minus 3x plus k. Now instead of x, let us put the values of x is equal to 1 in each of this. k1 square minus 3 times 1 plus k equal to 0. Now k times 1 square will give you k. 3 times 1 will give you 3 plus k equal to 0. If you move this minus 3 on the other side, then it will become plus 3. Now if you plus this 2k, then it will get twice k equal to 3. Now if you move this 2 on the other side, then it will become in the form of divide, that is 3 by 2. Since between 2 and k we have multiply, there is multiply. If we are about to move this 2 on the other side, then it will become in the form of divide. Now we got the values of k equal to 3 by 2, which is the required value of k. Guys, is it clear to all of you? If it is clear to all of you, then that's all for today. Wish you all the best. Thank you.